Hi everyone, this is Marianne for the 6th International Colloquium of the Latin American and Caribbean Space Network of Relaca Espacio, with the theme Space at the Service of Society. Today, I will be presenting my paper under the Space Law session with the title Application of the Legal Regime of Outer Space in Accordance with Sustainable Space Exploration and its Relevance to Society. Once again, I am Marianne Ong, second-year aerospace engineering student of Airlink International Aviation College, Philippines. The dawn of the space age started during the launch of the first artificial satellite, which is the Sputnik in 1957. After which, the United States of America established a new government agency which handles space explorations in their country, which is well known as the National Aeronautics and Space Administration, or NASA. Okay, so right now, let's focus about the current space environment scenario what we have. Did you know that any launch to outer space create and produce space debris? With 6,050 launches since the Sputnik artificial satellite, 11,370 satellites have been put at the near-Earth orbit, and 2,900 non-functional satellites are in there. As a result, humanity has been affecting outer space significantly. With the orbital velocity in LEO, or what we call the low Earth orbit, which is 17,400 mph, or converting it to 28,100 km per hour, with 1 millimeter in size of an object, once it collides with functional satellites or any objects, it can create to another collision and any catastrophic event, which leads to Kessler's syndromatic code. Let us know that outer space is not just the aspect to worry about when it comes to space debris, because thus the Earth and its society itself is really also be affected when it comes to this. So measures to mitigate and remediate sustaining the outer space environment under the regime and legal concepts of the international space law are needed to protect and maximize the service of space can provide to its society. So now, the following are the articles that provide points on the space activities relating to decreasing damage to the outer space environment. First one is the Article 1, Paragraph 1, which states that nobody can claim space as its own. Next one is everyone has the freedom to explore the moon and other celestial bodies for science and technology. Certainly, it is acceptable that mankind can access space at any time. However, the term freedom does not express free actions without abiding the law. Freedom in outer space is identified by participating and cooperating on the set agreement, treaties, and principles under the United Nations. Second one is Article 7. Once the object is launched, the party is liable to that object that may damage other state parties, components, or part of the Earth. Inside or outside the Earth's atmosphere, space bodies that include celestial bodies and the moon. This pertains to the space agency or program is on hand whatever destruction their object may cause. This applies with other objects in the outer space as well. Okay, next up is Article 9. Article 9 states that all states shall be working in the principle of cooperation, potentially keeping the outer space as a safe space environment. Any harmful event that may affect outer space shall be withdrawn and discussed. The term exploration does not necessarily for the sake of profit and taking advantage of the space resources. Rather, preferably, and shall be in line with scientific discoveries. For humanity to achieve this, state parties shall unite and commit of using the right materials that cannot contaminate nor harm the outer space. Okay, still part of the Chapter 2 is the Registration Convention of 1975. This states that all objects should be registered first, including the launching of the state or the name of the state or states. Next one is the location or where it's designed to be put. There must be a registration number as well, date, and the basic orbital parameters, which includes nodal period, inclination, apogee, perigee, and of course the function of the space object. So now let's proceed to some space debris mitigation guidelines. When we say the term space debris is defined as man-made objects, of course. These guidelines came from IADC and UNOOSA. Okay, so from IADC, they set a protected regions, which are called the low Earth orbit. From the Earth's surface, it is 2,000 kilometers, and the geosynchronous Earth orbit, or GEO, which is in 35,786 kilometer. It has a lower and upper. Lower is minus 200 kilometers, and upper is plus 200 kilometers. Materials used in spacecraft correlate to the structural components that can survive the environment in space. Variables including temperature, gravity, radiation, pressure must be able to overcome, and such materials that can withstand collisions to any space objects. Lightweight materials are fuel efficient, and high strength materials have the integrity to remain stable in the vacuum of space. First one is aluminum and its alloys. Traditional satellite materials are vulnerable to producing orbital debris. Paint flakes that protect the exterior releases debris, chips that move so fast in orbit that can hit other spacecraft. For this reason, aerospace engineering materials have been improved to meet the thermal and atmospheric conditions in space. UV radiation produces atomic oxygen, such as O2 molecules, to dissociate, and the atmospheric drug due to high level of thermospheric density. Aluminum is widely used in the industry as one of the materials to choose from when manufacturing spacecraft. To make it even more durable, aluminum is reinforced with alloys. The aluminum alloy that has been developed to meet the criteria, especially the satellite electronics, is aluminum beryllium. It is 62% of beryllium and 38% of aluminum. So the material's density for structuring satellites is 0.076 pound per cubic inch, with a modulus of elasticity of 193 gigapascals and a melting point of 1287 Celsius. Another thing that needs to be considered is the cost. Comparing the aluminum beryllium to traditional metallurgy satellites that cost 10 to 25,000 per pound, it is far cheaper, decreasing the cost up to 10,000 per pound, including the machining and the fabricating budget. So taking into consideration that a satellite after its mission is just merely nothing, thus it just adapts to, millions of objects out there at the orbit, resulting in collisions, accidents, space traffic. That is why post-mission disposal is very, very important and necessary. Now, it is a critical topic to the aerospace and economic industry because every satellite has its own. First one is the function, weight, and orbital position. So for this reason, disposing of each one of them requires a whole process from the launch, mission, and of course the disposal. Now, due to the different functions of satellite orbital parameters as well, the lower orbit disposal requires burning up during the re-entry period to the Earth's atmosphere. Through the lowering of satellite, making sure that the satellite will not enter the Earth. So the disposal is intended for small satellites only that can be burned up. For larger satellites, it would require to the orbit to a higher orbit and propel it to the synchronous, or what we call the graveyard orbit. So okay, the fourth chapter, the relevance of space sustainability to society, to you. So why is this important to us? First off, society benefits from the service of space. Yeah. For more than 5 decades of space exploration, humans have been fulfilling curiosity to the universe we live in, whilst continuing the provisions of space to societal benefits. As the main reason for exploring space is to give back to Earth, right? Now, the following are the aspects where space exploration play a decisive role in giving services to space. So let's tackle each one of them. First is the advancing scientific and technical knowledge. As science is the systematic study and practice of the physical and natural world, humans have been looking into more possibilities, right? Beyond the world. Now, the space environment, as I've just said, is far different from Earth, especially the gravity, temperature, radiation, pressure, and more. Thus, it gives a wide array of what humanity can discover and explore beyond Earth. Scientific research and what we call the technological advancement from space and create essential data for providing new innovations and solutions to address different problems here on Earth. Second one is the healthcare and medical science. Space biology introduces the study and research of living system and how it affects them when in the environment of space. Astronauts are experimental humans launched in space to study their physiological and psychological responses. Moreover, organisms such as microbes, cells, several innovations have been made in the aspect of healthcare because of space. As in, a lot. The If I give you example, there will be the surgery process, heart monitors, and technologies that have been used in hospitals. So all of them are because of the study done in outer space. Next one is addressing climate and environmental problems here on Earth. Well, the warming of the climate system has been a worldwide problem. Yes, I know that. We know that. We all know that. And the major cause of it is because of the GHG or the greenhouse gas. Satellites launched into space have been monitoring the signs of climate change in regions, especially in the Arctic. Hence, giving technical data that can only be gathered from space is essential to mitigate and adapt to the scenario that we are into right now. So another one is on the economic aspect. This is really important. If I'm going to ask you right now, have you ever used GPS or the global positioning system while navigating, just going to one town to another town? So this route information, the one-click navigation, came from space, from satellite-based technology. So another way is from television, radio, as in everything that those advancements that you can be used right now. This is important especially for those who are in the remote areas who needs potable clean water. Another one is job opportunities, generate revenues for the nation itself, for the country, which opens chances for international collaborations to each nations and states. Okay, to sum it all up, the reason why I went to this topic, which is space law, it's because law is the only way, I think, to govern this space agency, to make something happen. Because all of us right now, we all imagine this beautiful future, this exciting future of another life from another planet, another possibilities, opportunities, advancements. But if we do not protect the present, how can we even get to the future? So yeah, those can only be met with sustainable space exploration and following the guidelines and treaties that have been made. But then yet, a development would be a really great leap. So once again, yeah, I guess that's it. This is Marianne Ong under the space law session. The title, Application of Legal Regime of Outer Space in Accordance with Sustainable Space Exploration and its Relevant Society. I hope I impart some knowledge to you, everyone who's watching this. Thank you so much. Adios.